So let's look at some more complicated graphs for our absolute value functions. So what we're going to focus on is if we multiply with something on the outside of the absolute value, if we add or subtract something with x, and add or subtract something on the outside of the absolute value function. So let's make a table of values here. So what we're doing is plugging in these values into our function. So when we're at -2, we'd have 2, absolute value of -2 minus 1, and then minus 3. And then we're just going to simplify that down. So 2 with an absolute value of -3 minus 3. So now we can simplify the absolute value. So that's just 2 times a positive 3 minus 3. So 6 minus 3, which is 3. So what we get out of that is there's this coordinate -2, positive 3. And then we're going to do the same thing for the rest of these. So if we plug in -1, we'll have this 2 absolute value of -2, which will be 2 times positive 2 minus 3, which is 1. So we have this coordinate -1, positive 1. If we plug in 0, we'll have 2 times the absolute value of -1 minus 3. So that's 2 times positive 1 minus 3, so that's a -1. So we have 0, -1. If we plug in positive 1, so we'll have a 1 minus 1 minus 3, which is 2 times the absolute value of 0, which is just 0. So this is going to come out to a -3. So 1, -3. And plugging in 2 will be 2 times the absolute value of positive 1 minus 3. So 2 minus 3, which is -1. And we're almost there, plugging in 3. So we'll have 2 times the absolute value of 2. So 4 minus 3, which is 1. So 3, 1. And last one, but this is good practice for plugging into absolute value functions. 2 absolute value of 3 minus 3. So 6 minus 3, which is 3. So 4. Alright, let's plot these points. So we have our y-axis and our x-axis. We have -2, positive 3. I'll do a scale of 1 and 1. -1, positive 1, 0, -1, 1, -3, 2, -1, 3, 1, and 4, 3. Alright. Ooh, I missed something. Because I don't have a straight line there. There we go. 2, -1. I just put the dot in the wrong spot. Alright. Here is our function. And put some arrows at the end because it's going to continue on forever. Alright, so let's look at the coordinate for the corner of our function. So that's occurring at 1, -3. And with that point, let's look at our original function and see how those values come through. Because we can actually see the corner in this original form right here. The 1 is what's next to x. So our x coordinate for the corner is next to x. Something to notice is that we expect subtraction there. So when it's subtraction, the x coordinate is positive. If we had addition right here, it's like we would have minus -1, so then our x coordinate would be negative. So punchline to that is subtraction means positive x coordinate, addition means negative x coordinate. And then for the y coordinate, you just copy down what's outside. So there's our positive 1, -3. So knowing my absolute value functions, what I could do is in this original form, I could automatically see where my corner is, and it would be 1, -3. Whether our function is opening up or down. So what that means is up looks like a V, down would be the opposite direction, where it opens down. So in our case, it opens up. What that's coming from is that value of 2 on the outside. So now what we're going to do is kind of focus on this 2 on the outside, and it's because that is positive that it opens up. If that 2 was a negative 2, then what we would see is we'd have that same corner, but our graph would be opening downward. So this is because 2 is positive. Alright, the last piece I want us to notice are the slopes of the 2 lines. So on the right hand side here, to get between 2 points, I would go up 2, right 1. So what I have over here is a slope of positive 2. On the left hand side, we go down 2, right 1, and that would show you my slope of negative 2. So like I said in the previous video about absolute value functions, is numerically we're going to have the same value, it's just one side will be negative and one side will be positive. And what we can see is the actual value for the slope is coming from this value of 2 right here. That's telling us the slope, and then it's also telling us whether it opens up or down. So where we can get is skipping this table of values and just reading from this equation how we would graph that line. So let's see how that comes together in this next example here, where, I should actually answer this. Negative 2 and 2, and it's that positive number that we're seeing in our equation. Alright, so let's put that idea together based on this graph here. So I need the corner, which is occurring at negative 2, negative 3. And I want to use the slope, which, okay, so I'm also going to notice that this is opening up. So I'm going to have a positive value multiplying. And then for slope, we're going up 1, right 1. So we're having a slope of positive 1. So, making my function, I'm going to have a value outside, my absolute value, and then something adding or subtracting outside. So, in fact, a general form, let me just write down, we could have a x minus h plus k as a general form, where this is coming from the slope and positive or negative based on opening up or down, and then h and k make the corner. And just notice that we expect subtraction in there with x. Alright, so for our function, a is positive and a slope of 1. So I actually don't need to write anything out here. I technically have a positive 1 where a is, but it's redundant to write that, so I'm just going to go straight to my absolute value piece. But the idea is that a would be positive 1 based on the slope and the fact that it's opening up. Now my corner, so x minus h, so again we expect subtraction. What I'm plugging in for h is the negative 2, so that's what's going to make it positive 2. And then for k, we just copy whatever y is, which is a negative 3. So this right here is a function for the graph that I'm seeing over there based on the corner of the graph, and slope and direction that it's opening up. For a number out front is just we have a positive 1 there because of the